Now, the same formulas I just gave you, I was talking about usually using them with money. We can also use them when we do population. Population, they would change the formulas just like this. This is the same thing. This is A equals PERT. I mean, there's nothing different from these. It's just they change what the values are. NO would be the starting amount, like population. Still E and K is your new rate. And over here, this is just like the continuously compounding, but the problem is we're just saying that n is 1. Not the problem, but this would be this formula. It's just now n equals 1. If n equals 1, it goes away. So that's these. So here, let's look at example 6. It says the state's population is declining it's going down 2.6% annually. The state currently has a population of approximately 11 million people. If the population continues to decline at this rate, predict the population state at 15 and 30 years. So it's losing 2.6 annually. That's going to be the formula. That was like this. Because it's losing it annually, not that's just per year, okay, not continuously like this one, like this formula. It's not continuous, it's just a rate per year. So we're going to use that value there, or that formula, and we'll plug it in. It originally has 11 million people, and it's going to decrease by negative 2.6%. All right, it's negative because it's decreasing. So we have that, and we're going to do this for 15 years, and we'll also do it. So we'll do 15, and then we'll also do it for 30 years. So let's go to the calculator here. I'm just going to clear all that out of there so we don't get confused. We'll go 11 million, so 11 followed by 6 zeros, power of 1 minus my 2.6% decrease, and we do this for 15 years, and then we're also going to do this, and we're going to see what happens when we look at 30 years. Now, if it's decreasing, it should decrease more over 30 years. So there's my populations there. So 15 years. I'm going to round this to millions. So that'd be after every 3 decimal. We have 7.409 million. And 30 years is, if I do it again to millions, 4.99. This 6 would round up, so let's say 4.991 million. All right, and now we have a second part to this. It says now we have this, but it says predict the population if it does this, but now we're doing continuously, so not annually, continuously. So this would be the formula. It's kind of like A equals PERT, but it said that A equals in 0 e to the power of kt. So I put in again, we're going to have 11 million times e, and this is my rate is negative 2.6%, and it's going to multiply by 15 and then another time by 30. So let's go to the calculator over here. 11 million, I didn't do the 11, I'm sorry. 11, 1, 2, 3, 1, 2, 3 times e to the power of negative 2.6%. And we want to multiply this for 15 years. And then we're going to do it again. And we're going to change this now to 30 years. And so what happens to my population? It appears to me that the population is larger than. So we would have these values here. So 15 years, population is 7.44. That would become 8 million. And 30 years, we would say 5.042 million. So you can see they're larger again than they were at the previous times. And that's just kind of how it works. Though with the E, it's always a larger value. So now you have these to